All right, so here's the second part of the review. And we realized a pretty important typo that was left off was the divisors. It said to divide out the given factor of the polynomial, and they weren't printed on there. So you need to make sure that you add these polynomials to these 4 questions. Okay, so what I highlighted in yellow for some reason got cut off, wasn't printed on there. That was a mistake, but those definitely need to be there because that's how we start the problem. So we're going to state how many zeros are possible, how many turning points are possible, and then divide out that given factor, write the completely factored form, and find the zeros. Okay, so these are a little bit longer. They're asking for more things. Okay, so here, how do we know how many possible zeros and turning points? Do y'all remember that from our notes? That was in part 1 when we talked about zeros. We said look at the degree of the function. What's the degree of the function? The highest exponent, right? So in this case, it's a 3. Okay, that's our n value. How many possible zeros there are? That's n. Whatever n is, that's how many possible zeros there are. And then the possible number of turning points is 1 less than that. It's n minus 1. Okay, so here there are 3 possible zeros and 2 possible turning points. Does that make sense? Okay, it's just identifying that number. Now we want to actually do some dividing here. Now, this is different than what we've done in the review so far because this is not in the form x minus c, is it? So some people in these situations just prefer to do long division. They say, well, I'll just do long division if there's a coefficient in front of my x here. Okay, but there is a way to still do synthetic division. There's just the extra step. Okay, so I think we have 2 of the, yeah, this one also has it. So I'm going to do one with long division and then one using the extra steps of synthetic. So I'll do the synthetic first. Okay, so remember, if there is a coefficient here, okay, our extra step is going to come, there was 2 methods. You can go back and look in the notes at the 2 different ways. The way I'm going to do it is I'm going to say, okay, what would happen if I solved this for C or for, excuse me, for X? What would C be if I wanted to rewrite this as X minus C? Okay, so you can think of it as setting it equal to 0 and solving for X. Okay, what would that come out to? I'd have to subtract the 1 over, right? And then divide by 2. So wouldn't it be negative 1/2? Do y'all agree with that? Okay, I would have to subtract the 1 over and divide by 2. So negative 1/2 is what's going to go in my box. Okay, so then my coefficients, they're in order, so the highest degree. So 2, 5, 4, and 1. So I do the process is drop, and then I do start my multiply, add, multiply, add, multiply, add pattern. So negative 1/2 of 2 would be negative 1. Okay, when I add that, I get 4. Negative 1/2 of 4 would be negative 2. And when I add that, I get positive 2. Negative 1/2 of 2, again, would be negative 1, which leaves me with a remainder of 0. So that's good. Okay, no remainder. That means that that was indeed a factor. Okay, but this is not my quotient yet. Because remember, because of that coefficient, I have to divide that coefficient. In this case, it's a 2. So that 2 has to get divided out of my quotient of everything. Okay, so I have to divide all of those by 2. So this becomes, remember it was cubed, so this is squared. So 2 divided by 2, that's just 1. So 1x squared. Okay, that's 2x. And then that's a 1. So this is my actual quotient. That's not what I wanted to do. I wanted to highlight in blue. Okay, so that's the quotient. Okay, that was the divisor. Okay, but they asked me to get it in completely factored form. Okay, so I have to factor this quotient a little bit further. So x squared will factor to x times x. The only factors of 1 are 1 and 1. And they would have to be the same sign to multiply to a positive, and I want them to add to a positive too. I want them both to be positive. So x plus 1, that's the quotient factored. But don't forget this original factor that I took out of 2x plus 1. Okay, that's still there. So I have 3 factors. One last step, it says to find the zeros, right? Yes. Okay, so finding the zeros is setting this equal to 0. You remember split and solve? So I set each one of these equal to 0, or you can just think of it in your head and then solve it. Now these two are identical, aren't they? These first 2 factors. So I don't have to solve both of them. I don't have to solve it twice. It's going to come out exactly the same. What's it going to come out as? Yeah, if that was set equal to 0, I'd have to subtract the 1 over. So x equals -1. Okay, and then this one, that's the one I already checked. If I subtracted the 1 divided by 2, that's the -1/2. That's the one I checked up here already. So those would be the zeros or the x-intercepts for that one. -1 and -1/2. Okay. All right, now this one's going to be a tad easier. We don't have that extra step of having to divide out the coefficient because there is no coefficient. So I just know my C will be -1. That's what's going to go in the box here. Okay, and then I've got 3, -1, -3, and +1. Okay, so my process is drop the first term. Then I'm going to multiply and get -3. And then I'm going to add, get -4. Then I'm going to multiply, get +4, add to 1, multiply to -1, which adds to 0. So good thing again, it worked. That means we did the work correctly. Okay, because they told us this was a factor. Okay, so this is my quotient. Okay, I don't have to divide anything out of it because there was no coefficient here. So this is 3x squared minus 4x plus 1. Okay, but I need to factor this further because that's the quotient. Okay, and then the factor that we already took out is the x plus 1. Okay, but the red part, the quotient can be factored further. The only factors of 3 are 3 and 1, right? So this has got to be 3x and 1x. And the only factors of 1 are 1 and 1. Okay, but they have to be the same sign, and in this case, they have to be negative because you see we want a -4 in the middle. Because remember, outer, that would be -3x, and inner, that would be -1x, which would combine to the -4x. Okay, so that's completely factored now. And we split and solve, right? We set it all equal to 0. We're going to individually solve each of those. Okay, so the x plus 1 equal to 0, I would have to subtract the 1. So I get -1. Here I would have to add the 1 over, so I get positive 1. Okay, and here I would have to add the 1 and divide by the 3. So it would be positive 1/3. So those are the zeros of that function. Those are the places where it would cross the x-axis if we were to graph it. Good? All right. Now, 9 is another one that has the coefficient in front of the factor, in front of the x in the factor. But this also has a GCF. Okay, so I gave you a hint here. Okay, looking at these, notice there's no constant. So you could take an x out first and make your factoring a little easier. Okay, or you could take the x out later and make your factoring easier. I'm going to just knock it out now. I'm going to go ahead and factor out the x. And that would leave me with 2x cubed minus x squared minus 2x plus 1. Okay, and I'm still going to divide out the 2x minus 1. Now, I'll show you this one. I said I would show one long division. So I'll do one long division. I'm not going to worry about this factor that I took out already. I just can't forget about them later. But I'm not going to worry about them right now. Right now, I just want to take the 2x minus 1 out of this cubic expression. Okay? So the 2x cubed minus x squared minus 2x plus 1 divided by 2x minus 1. So remember, in long division, you are only focusing on one term at a time, just that leading term. Okay, so I'm just asking myself, what is 2x cubed divided by 2x? And that would be x squared. So that goes here. And then remember, you multiply by this binomial over here. So you have to, it's like you're distributing it. So that gives you 2x cubed minus x squared. And then you draw your line and change your sign. And here, everything reduces. That's a 0. Okay, then you bring down your next term. So if it's a 0, you're looking at that first term. What is 0 divided by anything? 0. So I'm going to put that here. It's just going to be a placeholder for now. That means there's going to not be an x term. Okay, and if I multiply that, of course, that's all zeros. Okay, and so that's still negative 2x. And I bring down the next term. So now the first term I'm looking at is negative 2x divided by 2x. That would be negative 1. So negative 1 goes here. And when I distribute that, I get negative 2x plus 1. But then I draw my line and change my sign, and everything cancels to a remainder of 0, which is great. It was supposed to. That means that worked. That is a factor. Okay. Now, what I get when I divide that factor out is x squared minus 1. There's a placeholder here. So when I write completely factored, I've got the original x that I factored out. I've got this binomial 2x minus 1 that I just factored out. And what I'm left with is x squared minus 1. Now, you could stop here for factored form, but technically this is a difference of 2 squares. It could factor slightly further because they're both perfect squares. The square root of x squared is x, the square root of 1 is 1. And you do one positive and one negative. Okay. And then we've still got the 2x minus 1 and the x. So when I set this equal to 0 and split and solve, I get 0. Here I would get, I would have to add the 1 divided by 2, so I'd get positive 1/2. Here I would get negative 1. And here I would get positive 1. Okay, So I had 4 zeros there. Oh, and I forgot to say how many, I forgot to do that on the last two. How many possible? This one, there should have been 3 possible. Okay, so 3 possible, and I came up with 3. And there would have been 2 possible turning points. On this one that we just did, there would have been 4 possible zeros and 3 possible turning points, and we got all 4 possible. Okay. You do not have to do that with long division. You could have done the synthetic division, but I wanted to show at least one example of long division for those who do like to use it. Okay, I'll do that very last example, I guess, in another video since the bell's about to ring.